Welcome to FYI, the 4-Year Innovation Podcast. This show offers an intellectual discussion on technologically enabled disruption, because investing in innovation starts with understanding it. To learn more, visit arc-invest.com.
ARC Invest is a registered investment advisor focused on investing in disruptive innovation. This podcast is for informational purposes only and should not be relied upon as a basis for investment decisions. It does not constitute, either explicitly or implicitly, any provision of services or products by ARC. All statements made regarding companies or securities are strictly beliefs and points of view held by ARC or podcast guests, and are not endorsements or recommendations by ARC to buy, sell, or hold any security. Clients of ARC Investment Management may maintain positions in the securities discussed in this podcast.
Welcome back to FYI. I'm Tasha Keeney, Director of Investment Analysis and Institutional Strategies here at ARC Invest, and today I'm joined by Daniel.
Hi, I'm Daniel Maguire, a Research Associate on the Autonomous Technology and Robotics team.
Today, Daniel and I had a great conversation with Don Burnette, founder and CEO of Kodiak Robotics. Kodiak is an autonomous trucking company. Daniel, tell us a little bit about Don.
Sure. Yeah. So as Donald mentioned in the podcast, he has more than 10 years experience working on self-driving software development. Firstly, beginning his career at Google, self-driving car unit, the predecessor to Waymo. Subsequently, Don left Google and then co-founded Otto, which was the first self-driving truck startup. This was then acquired by Uber. And after a couple of years at Uber, Don left to set up Kodiak Robotics.
So much experience in autonomous trucking. And actually, we care a lot about autonomous trucking here at ARC. And Kodiak actually popped up in our Big Ideas report this year. Daniel, tell us a little bit about what you found.
So as Tasha mentioned, Tasha has been looking at autonomous vehicles for a number of years, as well as trucks. And we think the importance of proprietary data in autonomous vehicles could play out in autonomous logistics. So we looked at autonomous trucking companies, those with data publicly available. And it looks like Kodiak is the leader in that regard in terms of real world data. So far to date, they've collected more than 2.5 million miles. And Don will elaborate in the podcast how that's helped them to achieve where they are in the market today. And then zooming out in terms of autonomous trucks, why do we care about this, Tasha?
So in the autonomous logistics space, autonomous trucking is an important component of that. We think there'll be roughly $400 to $500 billion of revenue in autonomous trucking by 2030. So similar to autonomous ride hail, you'll hear on the podcast, this is a technology that is really here today. We have autonomous trucks operating. It's just a question of when will it scale? And we think that's actually possible in the next 10 years. So, very prescient that we're talking to Kodiak today. Can't wait to get to Don. Let's head over. Welcome back to FYI. We're here with Don Burnette, founder and CEO of Kodiak Robotics. Don, thanks so much for joining us.
My pleasure. It's great to be here.
So I'd love to dive right in and hear your founding story. Why did you start Kodiak?
Well, I've been in the self-driving space for over 15 years. I started as a researcher at Carnegie Mellon. That was at the time of the DARPA challenges kind of coming out of that era. And I was fortunate enough to be able to join the self-driving car team at Google when it was first getting off the ground. I spent about 6 years at Google working on a lot of the foundational aspects of this technology. And there was a time in the industry where folks were trying to figure out where this technology was going. There were a lot of folks who thought robotaxis was the answer. That was where they wanted to focus their time, personal mobility, urban transportation. A lot of folks in the early days really wanted this to be impactful for people's daily lives. But for me, I really felt like there was a huge opportunity in the commercial market. So I got particularly excited about the long-haul trucking space. And that's when I decided to leave Google. I co-founded Otto, one of the first AV trucking companies, made a ton of great progress there. Really proud of the work we did at Otto. Ended up getting acquired by Uber. So I went through an exit, went through a joining of teams. And that was a fun experience. Did that for about 2 years. And once again, for me, I found myself in a situation where I just really felt like the commercial opportunity was what I wanted to pursue personally. So I ended up leaving Uber and founded Kodiak. That was back in 2018. It's been over 6 years now. It's been a pretty wild ride. I've been through all the ups and downs, all the hype cycles, all the excitement, booms and busts of this industry. So I'm excited to see where we are and where the technology finally is in terms of practical applications in the real world. And we're finally on the road and it's about to take off.
Great. Yes. And, here at ARC, we're big believers in autonomy in general. So we do look at autonomous ride hail, but autonomous trucking, we also think is a huge opportunity as well. Let's talk a little bit about the competitive dynamics in the industry. As you said, it's kind of been, a roller coaster for the industry as a whole, I'd say. There's a handful of other companies working on autonomous trucking, but that number kind of seems to be dwindling by the day. How do you see Kodiak versus others? And, what is it about autonomous trucking that sort of, is sort of weeding out these other players?
Well, there have been a lot of entrants in the autonomous trucking space. There's been a lot of entrants, a lot of companies in the autonomous space in general, but it turns out it's a really hard problem. And I believe that experience plays a large role in knowing how to build and how to shape a company, but also how to build the technology in the right way so that it's adaptable enough, so that it's generic enough, so that it can actually solve a lot of the use cases that you ultimately just need to solve to build a real product, right? That at the end of the day, it's not so much a research project. It really is about getting to a production level system. And that takes just a lot of knowledge, a lot of experience, and quite frankly, probably a lot of luck as well. But I think we've made some strategic decisions at Kodiak that have allowed us to stay really efficient with our team. We've hired the right folks to work on this problem. And we've made some technical decisions that have allowed us to really extend the technology to lots of different domains and lots of different environments. And that's really exciting from a customer perspective, which vis-a-vis becomes exciting for an investment perspective. And so investors really believe in the vision that we're building at Kodiak. We think we have the right approach when it comes to building the technology and taking it to market. I'm sure we're going to get a chance to talk about the details of those types of things, but it's not trivial. You can't just be a smart person, get in a room with a bunch of other smart people and bust out a self-driving vehicle that's actually going to work in the real world. There's a lot of methodology and systematic validation that goes into it. It's just a really hard problem.
I hear you. I'd love to talk about some of those technical differences. So, you all do not use mapping. Some competitors do. What made you decide to go that route?
This is one of those great philosophical questions in the self-driving space. So if you go back to the 90s, early 2000s, there was this really large push around the topic of simultaneous localization and mapping. We call it SLAM in the robotics space. It was really heavily researched at the time. How do you build a map of an environment, and how do you localize yourself within that environment? Localization, for the listeners, means where am I in the world? That could be a GPS coordinate. That could be a relative distance, like I'm 10 meters from that stop sign and I'm 20 feet from the curb on the left. And so I know roughly where I am in the environment. And if you know where the stop sign is and you know where the curb is, then you can triangulate where you are in the quote unquote world. That's effectively the challenge, which is to say, where is the vehicle on the road? Where is it in the world? And the way that we collectively went about solving that in the early days is we built these really detailed maps of the world. So we'd go out with our sensors, our LiDARs, our cameras, our radars. We would read in all the data from the world around us, annotate all of that data really heavily down to like little teeny patches, like square centimeter patches of the world. And then when you go back out into the world, you can cross-reference what you see live from what you see in your map, and then you know exactly where you are. And that's really helpful because then you don't need to detect a lot of things online. So if you just know where you are and you know where the traffic lights are in your map, you don't have to detect the traffic lights in real time. That makes the problem a lot easier. And so this was a huge unlock for the industry in the early days. And pretty much every self-driving company, when they first get off the ground, the first thing they do is implement a mapping solution. At this point, it's a pretty well understood topic. You can download a mapping program off of GitHub, you can implement it within a matter of a couple of days, and you can get your robot out on the world. However, there's some systematic problems with this approach. The most obvious being sometimes the map goes out of date. And you map the world around you, and then somebody comes in and mucks up your plan. They come in and move the curb. And when you get back, your robot sees the curb and says, okay, I know where the curb is because it's in my map. But actually, the curb has moved relative to other things. And so now, what do you trust? How do you know if somebody's come in and moved the curb on you, or moved the stop sign, or moved the intersection, or moved the wall, or remapped the road? And it turns out construction happens a lot. Right? It's one of those things we don't always think about unless we're in a construction zone. But when you're running a self-driving vehicle, you encounter construction all the time. And that's particularly true when you go long distances on interstate highways, like we do with our trucking, our commercial trucking business. So we see 2, 3, 4, sometimes 5 construction zones, active construction zones every day on all the routes that we're driving across the southern United States. And so the world is always changing around us. I think the crux of all of this is to say we chose in the very beginning at Kodiak to not implement a mapping solution in the traditional sense, like what Waymo and Aurora and other companies have implemented, because we felt like it was just too brittle, too inflexible. Instead, our system relies on real-time perception, real-time inference about what does the road look like, where are the lane lines, where are people driving on those roads? What is the drivable surface? And that's exactly how you and I drive, by the way, right? We don't have a predetermined map of the world. We go out and we know what a lane looks like. We know where we're supposed to be within that lane, and we drive and we try to avoid hitting things. And that's effectively the way that we designed the Kodiak system. In the beginning, it was a gamble because we didn't know if it would be able to work reliably. Fast forward 6 years, I think this is one of the strategic advantages that we have as a company because it allows us to expand to new areas and open up new routes very, very quickly.
Yeah, and Tesla famously doesn't use maps as well in the ride-hailing space. And I've talked to some other companies, and the argument, at ARC, by the way, we totally agree with your approach. Mapping seems really hard to scale, and in addition to the these immediate challenges that it'll pose when things change, as you said. The argument that I've heard for it for trucking is that, well, okay, trucks take the same routes. So actually, like, the scalability issue isn't quite there as it would be in the ride hailing side. But from what I'm hearing you say, I mean, there's so many situations that could pop up daily where, your base truth, so to speak, would kind of no longer be true, which would present a problem. So it's a more difficult problem to solve, I think, what you're doing. But perhaps it's the more commercializable, more scalable way to go about it.
That's right. And I actually think it's the opposite of what you just claimed. If you're in a dense urban environment where there are, for instance, lots of fixed buildings that you can reference yourself to, those buildings tend not to move over time, right? Even if they restripe the lanes or restripe the roads, it doesn't help you know where the lane lines are, but at least it tells you where you are within the world. When you're out on the open road, and for the listeners, this is interstate highway, middle of nowhere driving. It's not your inner city highways or anything like that, like where you live. We're out in the middle of nowhere. There's nothing as far as the eye can see except some trees and some fields for the most part. So there's really nothing in the world to reference off of other than the lanes that you see in front of you. And it also turns out that lanes look the same. Right. And so you could be moving up and down miles at a time and the images all look the same. So where exactly are you? It's a really hard problem. But at the end of the day, you still need to know if the world has changed. And the goal is to just drive the lanes as they're striped on the road. Right. That's what we do when we encounter an environment that has been under construction. And ultimately, that's what the autonomous vehicles need to do. So I think having a reliable way to detect lanes, roadways, drivable surface, and then understand the connectivity, that's ultimately the most important. And that's how we implemented our system.
And just on the mileage, we at ARC, we always talk about the importance of proprietary data, particularly for autonomous vehicles and Tesla's data advantage. And as part of our big ideas research, we started looking at it in autonomous logistics. And Kodiak, you have 2.5 million miles, I believe, of driverless data. How important is that to kind of achieve your efforts towards the driverless solution?
It's hugely important. We have, like you said, over 2.5 million miles driven in commercial operations. That's over 5,000 loads, or nearly 5,000 loads today that we've delivered. And we've been working commercially since 2019. We have some amazing partners, and we drive all over the southern United States. Our network consists of over 18,000 miles of interstate highway. So we've gathered a lot of data, and that data is hugely important for training the system and making it generic in a way that can handle a variety of situations. I would say, though, I would caution, though, there's a diminishing return to data, right? 2.5 million miles, 25 million miles, 250 million miles. At some point, the data becomes less valuable for every image or every instance of capture. And what we find is that the most important aspect of training the system is understanding how to curate the data and how to pick out the most important aspects. Like what data gives you the most bang for the buck, so to speak. That's where that's where the cutting edge research is. So you have to have enough data. You absolutely have to go out there and explore the world, see what your sensors see what the robot sees, teach it along the way. But there is definitely a diminishing return. And that's, of course, where simulation comes in, and you can augment the data set and you can modify the data set. And there's all kinds of techniques that are really exciting within that space.
You talked about how you've differed in terms of maps, and sticking with your technology platform for your approach that it seems to be adaptable to different form factors, perhaps a retrofit solution, if that's the correct term, or maybe it's not, you could correct. But yeah, maybe if you could just kind of elaborate more on that and how it could help speed your technology to the market.
Well, we've also gone into additional environments beyond just the highway. I think that's a really important piece for us. We work with the U.S. military, the U.S. Army, the DoD, to supply self-driving technology for ground-based vehicles in that setting. In those types of environments, you're going to have a lot less structure. You're not just driving on a highway with nicely painted lines. You need to be able to go on dirt roads, unimproved roads, out into the field, like whatever the robot encounters, whatever the vehicle encounters, as long as it's physically capable of handling that terrain, they need the autonomy system to be able to do that. So for us, it was a huge advantage that we didn't have to have a pre-mapped environment. Our system can literally drive into environments it's never seen before. And in fact, the Army has tested the Kodiak driver system specifically in that type of situation where they actually took our system into an environment, into a roadway, into a network that we had never seen, never touched, never been to before, and said, go. And the system handled it flawlessly. So this type of approach is really important for the handling a variety of types of environments. And that's one of the things that makes Kodiak system very unique. And when you talk about the different diversity of data that you kind of collect, it's important to have a wide variety of scenarios. You can't just see the same type of roadway, the same type of vehicles, the same type of merges over and over and over again and expect your system to generalize. So one of the strengths of Kodiak is that we are able to gather data from such a diverse set of environments, and that really helps robustify the system overall. In terms of the upfit of the system, we recognized early on that if we wanted to put our system onto many different form factors, and we've been targeting the DoD use case for many, many years. We started working with them seriously in 2022, but we had some other military programs even as far back as 2020. And so we recognized back then that if we wanted to have a single system, a single software, AI, and modular hardware platform, we were going to have to develop it in an independent way that would allow it to be upfit on many different form factors. So now we've taken our Kodiak driver system, we've put it on our semi-trucks, we've put it on an F-150, and pretty soon we're going to be on other vehicles as well that we'll be announcing. And so that was a really important step for us. If you build a bespoke solution for a given manufacturer, it doesn't allow you to then migrate that to other form factors and other footprints. That was really important for Kodiak.
Got it. And, you touched on what my next question was, which, to your point on data diversity, having commercial partnerships or, in this case, partnership with the DoD is important for, not sort of seeing the same road every day, right, when you test. Can I ask you, so because unstructured autonomy is so different than structured autonomy, maybe to help our listeners kind of elucidate, how does that information help you? Because it is such a totally different operating environment. How do you then apply that learning to traditional trucking?
Well, I think this is a really interesting concept, really interesting topic. I'm not sure it's the most interesting thing for everyone, but you can imagine when you think about the different variety of environments that we may operate in. An open field seems very, very different than a highway, right? But if you structure your algorithms in the right way, if you train the models to think about the problem in the right way, then you can actually generalize across these, and they're not all that different. So one of the concepts that we really focus on at Kodiak is the notion of a corridor. So what is a corridor? Corridor could mean anything. It's really not a well-defined term. But for us, it means drivable extent. Where can the system go right now? And there's different types of corridors. So on the highway, a corridor might be a lane, right? It gives you a boundary on the left and right, and the system knows I'm supposed to stay in between the lines. There's another corridor, which is the road extent or the boundaries of the roadway. I know I need to stay within those boundaries, and maybe if I'm trying to avoid some other object, I can depart my lane, but I usually don't want to depart the roadway. You can bring that same type of corridor concept into unstructured environments as well. It might be that the extent for the left and right boundaries are just very wide, right? And the objective is move toward the destination, generally given in some kind of GPS-like coordinate, right? We know the direction, the general direction that we need to travel. And the system dynamically figures out based on the platform it's on, right? If you're on a treaded vehicle, you can obviously go over more things than you can on a semi-truck. Based on the platform, it understands to the extent of the corridor it's allowed to drive. And that could be just very wide. It could just be an open field, in which case it's going to go straight, and then it's going to avoid objects like rocks and ditches and other types of things. But when you frame the problem in that way, the AI system can actually handle those types of environments with the same logic. And so it really is about finding the right definition of the problem that allows the AI system to map its internal logic to the problem that we would, the scenario or the environment as we would interpret it as humans.
Got it. That's so I have so many more questions on that, but I would love to ask you about, back to this other topic, when to partner, more closely with an OEM and when to sort of make your commercial partnerships or customer partnerships first. Like I would imagine that there are some technical advantages of just initially saying, this is the vehicle platform that we're going with, and this is what we're going to train on. This is our ultimate commercial solution. But to your point, it's like this kind of push and pull because there's data advantages. There's like a variety of scenario and learning advantages that you get in not standardizing on that right away. Can you talk about sort of how you thought of that strategically?
It's definitely one of those strategic conversations that you want to have continuously throughout the evolution of your company. What we thought we would do when we first started the company is much different than what we're actually doing today. And so you have to constantly reevaluate where you are, what makes sense strategically for you. I don't think there's a one size fits all, right? There's no right answer to this, but you just have to I describe it like a game of chess. You're always playing a game of chess. You're always trying to see around the corner. You're always trying to think about the next move and what comes ahead. Ultimately, though, one of the things that a lot of AV companies have lost sight of is the fact that at the end of the day, we need to provide a product that provides value so that we can make revenue and ultimately become profitable. So it's less to me about what is the long-term asymptotic, end state, end goal. I mean, you want to have that amazing mission of we're going to automate all of the transportation, all commercial vehicles. That's Kodiak's ultimate vision. But our specific mission is to find ways in the near term to commercialize our technology. In terms of working with various partners like OEMs, if you want to get to massive scale and massive adoption, then going with the OEMs and working with the OEMs is the only path forward, right? If you want to produce 100,000 vehicles, 1 million vehicles, you're not going to be able to do that any other way than very close partnership with an OEM. That being said, we think we need to get to 1 vehicle before we get to 100 vehicles, before we get to 1,000 vehicles, certainly before we get to 100,000 vehicles, right? And there's other ways to approach the problem and other ways to monetize this technology in the short term that doesn't necessarily mean produce 100,000 of these vehicles. So our focus has not been so much on scale. I actually think scale is a red herring. Everybody wants to know, yeah, you can do one, but can you do a million? And I think that's the wrong question because nobody's done one yet in our space. And we really want to get there before we try to get to the ultimate scale. And so we can produce smaller quantities in various other fields, such as the DoD, as an example, where the volumes are a lot smaller, where they're a lot low, but they still provide value. We can still generate revenue. We can still build our company as we work toward building that larger scale. We have great relationships with the OEMs. We haven't announced anything publicly on that front. I think we will at some point announce something publicly, but understand also that the OEM timescales are long and these programs are difficult. Everybody's working super hard and everybody believes in that future, but we didn't want to tie the success of our company to any given OEM timeline. Because when those timelines slip, you have to go raise more capital, raise more from investors, and at some point the pot might dry out. So we wanted to have independent paths and build a platform that we could use in various environments, maybe at lower scale to be fair, but at the same time, we can actually get a product out there.
And you mentioned timelines and profitability, and a big part of that is going driverless. And I know at CES you released the 6th gen, which got a lot of attraction and probably an important step towards it with the redundancies and the safety fallbacks. Maybe if you could talk about the timeline to driverless and what needs to be achieved, be it technologically or regulatory, to achieve that.
Sure. So there's the technological side and there's a regulatory side, as you said. Maybe I'll head off the regulatory side first. So right now in the US, it's a patchwork of state laws. Every state passes their own regulation or non-regulation about the performance requirements of self-driving vehicles, the permissibility of self-driving vehicles, the liability, all those different things. And so far, in all of the states that we operate commercially, which is the entire Sun Belt going across from Georgia, Florida, all the way to Arizona, and ultimately California being kind of the one standout state there. But every other state along those commercial lanes has given us the green light to go driverless. So regulatory hurdles are not really something that we worry about too much. Of course, we have to keep our finger on the pulse, right? We have to make sure that we're engaging with regulators at the state level, at the local level, and of course also at the federal level. And we're working really hard in that direction. But right now, we don't see any roadblocks to going driverless based on a regulatory framework. On the technology side, as you mentioned, we're super excited to have just announced our latest generation of the truck. The significance about this release is that it finally has all of the redundancies that we need to go safely deploy a driverless solution on public roads. So it has multiple brake actuators, 3 brake actuators actually for extra redundancy. Because if you lose your brakes, it doesn't really matter how good your AI system is, the truck won't be able to stop. And that's not an acceptable scenario for us, right? We have multiple steering actuators, we have multiple power rails, multiple alternators, battery backups, because again, your AI runs on power. And if you lose power, then you can't make decisions and you can't control the vehicle. So we had to make sure that at every step along that line, we had the appropriate redundancies so that if one system were to fail or even have a fault condition, we had a backup system that could take over, safely pull the truck over to the side. So we now have that platform. It has all the redundancy that we believe is required for safe and responsible deployment of driverless. There's still work to do. We now have to take the software that we've been working on for the last 6 years, pair it with that hardware solution, and complete the last steps of validation to ensure that we've actually checked all the boxes, we've dotted the I's, we've crossed the T's. We call that our safety case burn down. The team is working hard on that, and we're excited that we're going to be able to get to public roads when it's safe and prudent to do so. But it's coming very soon.
If I could quickly ask, I'd love for you to explain to our listeners why all of those redundancies are necessary for trucking, because it seems a little bit different than what's needed in ride hail. Why do you need 2 separate systems? Why couldn't you just have, the fail-safe system be the same, set of like brake mechanical operators?
Well, I think the first thing that listeners should understand is that it's really a philosophical question as to how much safety features do you need? How many safety features do you need? How much backup do you need to safely deploy this technology, right? And if you look at, for instance, a lot of the ride-hailing self-driving space, like the robotaxi space, I'll use Waymo as an example. I believe, although they haven't really spoken about their system, but I'm pretty confident that they actually do have redundant braking systems and redundant steering systems. So if they lose their steering motor, they have a backup that can still steer the car. And I think steering is a really good example, right? The typical steering wheel driven by a human is controlled by your hands, and you can physically turn the wheel, right? But in a robotic vehicle, you need to have a motor attached to the drive shaft. So the steering wheel is connected to a steering column, steering shaft, and then there's a motor attached to that has gears and it's powered and it can turn the steering shaft just like you would with your hands. But if that motor were to die, and sometimes motors die, right? They're not perfect devices. There essentially is no perfect device. Then you would effectively lose control of your steering. And I think the listeners can understand that if there's a car that has no driver and it has no ability to steer, that would be a bad situation. And so we believe that redundant steering actuators are required for safety because the chances of two simultaneous motor steering failures is astronomically low, right? The whole game is to reduce the likelihood that a failure can occur. So when you talk about, you frame the question in terms of rideshare. This is a philosophical question, right? Are there other vehicles that are trying to go driverless that don't have redundant braking, that don't have redundant steering? I don't believe that's true. But really, when you look at what companies have truly deployed a driverless solution, like Waymo, and they're one of the few exceptions at this point still operating, they do have redundancies, and we believe that those redundancies are necessary.
Got it. So you're saying it's across the board, doesn't matter where you're operating.
I believe that's true, yes.
And then can I ask a little bit about the sensor set choices that you've made? Because this is often where companies like to differentiate themselves as well. They'll for instance, like they'll make a proprietary LiDAR system or bring something in-house. What did you all decide to do? And what do you think is kind of the right choice for full autonomy for Kodiak?
Well, we use a full suite of sensing. We use pretty much everything available to us. We have LiDAR, we have camera, we have radar. And those are the three primary modalities that we use to see the world. They're also the most common sensors that you're going to find on a self-driving vehicle. LiDAR, of course, scans the world with light pulses. It gives you distances to objects, so it tells you exactly where things are in space, which is quite helpful. Cameras can give you texture and context about what the object is, and camera detectors and image detectors are obviously very well studied at this point, and those types of algorithms are very, very strong. And then radar is an extra level of sensing modality that can cut through dust, it can cut through rain, it can bounce around objects so you can kind of see through objects, and it gives you a rough positioning and velocity of objects around you. It also has very good range. And so when you take all of those different sensing modalities and you put them together, we believe that forms the basis for the strongest perception system that you can build for self-driving. Now, that being said, my opinion is that a lot of the differences that you see around the approach to perception in terms of what sensing people use is around cost. If you're providing vehicles to end consumers and you want to provide them with driver assistance features like what is available in so many vehicles today, you don't have the ability to add $50,000, $60,000, $70,000 worth of sensors because people aren't going to be willing to pay for it. But on the commercial vehicles, at software as a service, like what we're providing, we actually have more margin to put higher cost sensors onto our system. That gives us more reliability. The more sensors you add, the more reliability you're going to have, the more chance of seeing an object you're going to have. And some people would argue, well, having too many sensors is bad. And there are various reasons why that can be true. But we believe that LiDAR, for instance, which is the most contentious of all the sensors that people talk about, we think it provides a lot of value from a perception system because it tells you exactly where things are. And it has some weaknesses, but we can augment those weaknesses with strengths from the other sensors that we have on the vehicle. So at the end of the day, we deploy a full spectrum of sensing from LiDAR, radar, and camera. We think that's the right approach for fully self-driving, nobody in the cab, nobody in the vehicle driving. And in terms of internal development, we could probably do a whole conversation on that topic, but suffice it to say, it's very expensive to build your own LiDAR system. And there's no guarantee. In fact, the probability is low that your sensor, your LiDAR, the team that you've hired to build it is the best of the best. And so we're just playing the statistical game, which is to say, most likely the best LiDAR system that's going to be developed is going to be developed by the free market, right? The companies that excel to the top are the ones that are going to drive the most demand and get the most customers. They're going to be able to bring their prices down, which is going to allow them to increase their reliability and increase their performance, et cetera. And we've built our system specifically so that we can do rapid prototyping. We can try every sensor under the sun. We've worked with every manufacturer that you could probably name. We think we work with the best of the best. And if some new entrant comes along with a better sensor, we're able to pivot and we're able to swap to that sensor. So it saves on R&D dollars, and it allows us to be much more open to the broader ecosystem of what's possible and doesn't lock us into one solution. And that, at the end of the day, I think is the most prudent way to build the business in a world where you don't really know what the final outcome is going to be. You want to stay flexible and you don't want to burn billions of dollars on a path to nowhere.
Right. And probably also a prudent decision in the current macro environment as well. You mentioned software as a service business model. I'd love to talk about, how you see this commercializing, how Kodiak fits in with a broader trucking ecosystem, and sort of, what is the software as a service model? Let's talk about that.
Well, that's the great thing about this business is that we don't have to disrupt in a sense. We're not a disruptive technology in the sense that we're not changing the way that the industry works. We work with our partners, for instance, Werner, IKEA, Tyson Foods, some of the largest players in the trucking and shipping space. And we slot into their existing business exactly the way a traditional manual truck would. So we don't have to change anything about the way we do business. And we even charge them the same way that they're used to being charged today. Right now, the trucking market typically pays drivers as a per mile. So you get paid a fixed amount per mile, and the number of miles you drive over the course of a week determines how much you ultimately get paid. And so we charge as a service per mile for the use of the Kodiak driver system. We provide all the monitoring and the hooks into observability and visibility into the loads where they are. But ultimately, we monitor the safety of the system. And as in return for that service, we get paid by the carriers, by the trucking companies on a per mile fee. So we don't have to disrupt anything. We don't have to change the way they do business. We slot into the existing ecosystem exactly as it exists today.
And then on that charging per mile, presumably at the beginning of it all, you could likely charge similar to what laborers charge given the shortages. But eventually, when you kind of scale, is there potential to charge lower and as other competitors come in? Or how do you think about the pricing dynamic there?
I think pricing dynamic is going to be set by the market, right? How valuable are autonomous vehicles to the customers that are using them relative to the alternatives in the market? I mean, it's pretty straight market forces at the end of the day. We think that in the early days, something comparable to an existing rate makes sense, probably a little bit less because the technology is new and there's some risk associated with trying anything new in your very well-established business. And I think that that's fair. At the same time, you also have to recognize the benefits that autonomy brings to these companies, like increased efficiency, increased utilization. So our trucks can drive almost 24/7, whereas manually driven trucks are limited by hours of service. So each driver is limited to about 11 hours per day. But on average, trucks are only doing useful motion. They're only moving in a useful way for about 7 hours per day. So the trucks are very underutilized today, and we can nearly triple that asset utilization, which allows the companies to effectively triple their revenues for the same number of assets, right? So there's a lot of value associated with the increases in safety and utilization and efficiency that our technology can bring, much beyond what is the unit cost per mile. And so we're still figuring that out with our partners. And ultimately, I think the market dynamics are going to be in play here. And as more competitors come in, as the technology matures, the price will likely come down as the scale goes up. That typically is the way it goes. But you know what? It's still a very early industry, and it's hard to say where it's exactly going to go.
And you all announced a partnership with Ryder recently as well, which I know, Ryder has had some other partnerships in the autonomous trucking space, but tell us about it. Tell us what's unique about what they're doing with Kodiak.
One of the fundamental requirements of getting this technology off the ground is the need to have launch and landing points for the autonomous vehicle. So right now, the technology is not to a point where the autonomous truck comes into a loading bay, backs up the trailer to a loading dock, pulls away, drives down the highway, and does the opposite on the other end. It's not quite there yet. And so we still utilize humans on what we call the first and last mile. So the very beginning and very end of the route for hooking up the trailer, for fueling the trucks, for picking up and dropping off the freight. We still have a human in the loop for those tasks. So then the question is, where is the handoff? Where does the human get out of the vehicle? Where does the autonomous driverless vehicle actually start? We need launch and landing zones for that. And there's a lot of different types of infrastructure that you can imagine utilizing for that piece of the puzzle. We partnered with the Pilot company. They actually were the lead in our last funding round back in 2021. And we've been working with them. They're the largest travel center provider in the country as a partner to deploy these launch and landing zones. And we've had a really great relationship with them. But we also recognize that they don't necessarily serve every market. They don't necessarily serve every sector. And so we brought on Ryder as another partner in the infrastructure space, because we believe that working with the broader ecosystem for this purpose is, again, a prudent way to build out and scale the business, as opposed to building our own bespoke facilities that cost tens of millions of dollars and take a long time to build and aren't necessarily in the best locations, because companies like Ryder and Pilot and others have already bought up the best infrastructure. They've already bought the best land. They've already done the work to determine where are these facilities needed for the existing ecosystem. And again, since we're slotting into that existing ecosystem, we want to be where the business already is. And so the partnership with Ryder gives us access to their facilities, to their maintenance products. And it's a really exciting partnership that's going to allow us to rapidly deploy and rapidly scale our business all across the United States.
And I imagine it also allows you to, stay focused as the technology provider on making the truck drive itself, right?
That's exactly right. We want to work on the core technology. We want to focus on our expertise. Something that I think we've been very good at Kodiak is not getting distracted and not stepping outside of our zone. We don't develop our own cloud infrastructure. We don't build our own networking gear. We focus on autonomy software. That's our expertise. That allows us to keep our costs down while still making just as much progress as the rest of the industry, if not more. And this is just more examples of working with that broader ecosystem.
And then on the technology front, just to go back on, we at our kind of track a lot of AI, and it's seen significant breakthroughs in the last number of years. ChatGPT, I'm sure if you said that to someone a couple of years ago, they think you're speaking a different language. But curious if any of these breakthroughs have helped your progress towards going driverless, or if you've been able to leverage them. I guess getting towards that goal, if they've had a significant impact on that.
It depends on how you define significant impact. LLMs and transformer networks are really interesting, and we're definitely looking into ways to leverage those types of technologies on our system. At the end of the day, right now, there's slightly different problem than the general AI perception and scene understanding problem that we're trying to solve. That being said, ChatGPT, LLMs, that's just the latest craze that everybody's familiar with, because it's something that individual end users can interact with. But the state of AI has been exploding for years, right? Probably since about 2017, 2018, the progress in terms of all kinds of different frameworks and architectures has been, just exponentially increasing. And we absolutely leverage all the state-of-the-art advances coming out of industry, coming out of academia, coming out of our own research groups to make our system as robust as possible. We have over 40, just to give you a sense, we have over 40 neural networks running in our truck that do all kinds of processing, understanding, motion planning, decision making, prediction, you name it, all of the different types of challenges that you would encounter on the road. We have an AI that's handling that type of situation.
And on that, has there been an evolution within the company? You're saying 40 neural networks. Has that changed over time as you've learned more in the process? Have you changed any of, say, like your machine learning approaches behind the different pieces of those networks?
Well, I come from the days where we were just handcrafting, edge detectors for perception. And that was way back before this whole machine learning revolution kicked off with Google Brain and detecting cats in YouTube videos. I mean, that's where it all started. So I was working on self-driving well before that era. So I'm very familiar with the transition to modern machine learning techniques, not just at Kodiak over the last 6 years, but over the last 15 years as an industry. And it's been fascinating to watch. But yes, I think the techniques are probably changing every year. And one of the things where we're pushing the forefront is in multi-sensor fusion. So it's one thing to have a vision detector. It's another thing to have a LiDAR classifier, which basically says you have a LiDAR point cloud. What are the objects around you? That's a hard problem, but it's something that AI has gotten really good at. Even for humans, you look at a blob of points and you're like, oh, I'm not really sure what that is. But we can train AI classifiers that are really good at picking that stuff out. But when you throw all of the different modalities in together, how do you represent that data? How do you actually merge them? How do you present the AI frameworks with something that it can understand and it can actually learn? And then how do you craft your reward functions, right? At the end of the day, this is pattern matching software. So it sees patterns and it produces a result. And you have to craft what that result is, and you have to craft how you present the inputs, and then you have to craft the architecture. So there's a lot of different aspects that are going into the evolution of these nets. We're constantly learning. We're constantly trying new things. It's a really exciting area of research. I think that's why there's so many people that are going into that space now. But certainly self-driving is at one of the forefronts pushing this industry forward. Obviously, chatbots and LLMs and human-machine communication is another one. It's very exciting. I think there's a little bit of a tangential difference between the two, but nevertheless, a lot of the underlying techniques are the same. And yes, we're constantly evolving our system even as we speak.
I know we're coming up here on the hour. I'd love to ask you, is there anything that we didn't talk about today, or anything that you're particularly excited about in the future that our listeners should be aware of?
Well, it's been a long road to get here, no pun intended. And I'm just excited that we've finally gotten to a point with the technology where it just works, right? I'll go back to Waymo. Those vehicles are out on the road today. You can hail one. You can try it out. And it's a magical experience. I mean, there's no other word to describe it. It's absolutely magical what these machines are capable of doing. And the commercial market is a little bit behind the passenger car market and the robotaxi market in terms of deployment. A lot of that has to do with the actual hardware and platform and underlying systems itself. We're finally starting to overcome those challenges. We finally have the redundancies we talked about earlier in the show that allows us to deploy these vehicles out into the world. And it's a really exciting time. So I think the message, the takeaway of all this that I want people to understand is that this is not some futuristic, crazy technology. This technology is here today. It's ready today. It's being deployed today. It may not be in your backyard, but at some point, you're going to see self-driving vehicles out on the road. And very soon, you're going to see self-driving trucks as well.
I love that, because we get that question a lot from investors. When is autonomous technology going to come? What's the date? But, as you said, you heard it here from Don Burnette. Autonomous technology is here. And particularly in trucking, we're like just on the cutting edge. And we're so excited for the next year or so. Okay, Don, well, thanks so much for coming on our podcast. And we'll talk soon and get updates from you on Kodiak. Thank you.
Thanks, Don.
Awesome. It's my pleasure. Thanks for having me.
ARK believes that the information presented is accurate and was obtained from sources that ARK believes to be reliable. However, ARK does not guarantee the accuracy or completeness of any information, and such information may be subject to change without notice from ARK. Historical results are not indications of future results. Certain of the statements contained in this podcast may be statements of future expectations and other forward-looking statements that are based on ARK's current views and assumptions and involve known and unknown risks and uncertainties that could cause actual results, performance, or events to differ materially from those expressed or implied in such statements.